Hey, welcome back. Here we are at Unit 1-2. Thanks for hanging in there with me. This is our second lesson. We have quite a few together this year, and I appreciate you trying this new thing with us. Holt is your textbook, and it's going to be Lesson 1-5, Part B. So it's Chapter 1, Lesson 5, Roots and Irrational Numbers. Again, what's expected here, just try to remember, limit your distractions. I know it's easy to be distracted when you're doing stuff. I get distracted all the time. Just try to concentrate as best you can. Occasionally ask you to write some stuff down, put some practice problems in, and then at the end of the lesson, please give us at least one good question for myself or the class or what have you. Alright, so once again, kind of an overview. If you see the guy with the binoculars, go ahead and just watch. Don't have to do anything, no pencil, no pen. Just sit back and enjoy, and we'll see what happens. Okay, and again, just reminders there below. Add those to your notes and add practice problems to your notebook. Okay, still Standard 2.0. And today we will learn to simplify fractional roots. So just a quick rewind from yesterday. This we call the radical sign, and this, of course, what do you think is the radicand there? Hopefully you said 196. The radicand is indeed 196. Very good. And the square root from yesterday. So we're asking for the square root here of this number, 196. Do you remember from yesterday, what times what is 196? So if you flip back in your notes a page or two, you might see the number is 14. 14 times 14 is 196. So now, let's take a look at this. We can take square roots of fractions. And here's what I'd like to do here. I'm going to go ahead and give you a little information. This is probably what high school teachers are going to tell you. If you have a radical sign like this, and you have some real number A over some real number B, then what we can do is, first of all, we could try to simplify inside the radical sign. In other words, if this was something really simple, then we could reduce it first, and maybe get a whole number. So for example, let's just take a look at this. What if I said the square root of, 100 divided by 4? Well, we could just simplify this, couldn't we? What's 100 divided by 4? Well, we know that that's 25, and so the principal square root of that would just be 5. We'd be all done. But if we can't really reduce this, then this is more common. What we can do then is we can take this and go square root A over the square root of B. So in this case, if you take a look at this particular expression we're given, could we come up with radical 4 over radical 25? And what would your final answer here be? Well, in the numerator, radical 4 is, what's the square root of 4? Well, indeed, it's just 2. And how about 25? Well, in this case, it is 5, so 2/5, and you're all done. All right? So that's something that you can keep in mind. We can reduce first. This is kind of preferred. This is the way we prefer to do it. But if not, of course, in this case, we can't do anything with that. We'll just go ahead and take the radical of the top over the radical of the denominator there. Okay, now, think about this for a second. Do you think you can come up with your own perfect... Well, I'm using whole numbers here that are nice and perfect squares. Can you come up with your own that might work as well? So think about that for a second, and I'll write down the ones I thought of. So if you want to pause the video, write down 1 or 2 or 3, and then I'll throw some up here, and we'll see if maybe we got the same ones. All right, here's the ones I came up with. I came up with radical 9 over 100, 16 over 25, square root of 1/4, and square root of 49 over 64. And what do you notice about all these? All these are nice, perfect squares. Okay, and the textbook is going to be pretty friendly at the beginning. We're just going to do nice, perfect squares here. So we know that the square root of 9 is indeed 3, and the square root of 100 is 10. We can't really reduce that fraction, of course, in any way. So we'll just go take the top over the bottom and move forward. All right. So try these on your own. What do you think? Radical 25 over 81. So if you were to split that up, and we had something like this, I'll do the first one here with you. If we took this and we said, well, I know I can't really reduce 25 over 81. This isn't going to give me anything nice and friendly. So what if I did this? It's radical 25 over radical 81. Well, what is the principal square root of 25? Well, indeed, that's 5, right? And what is the principal square root of 81? Well, that's 9. And before we put a box around and say we're done, can 5 over 9 be reduced? The answer is no, we can't. Their common factor is 1. Put a box around it, and we're all done. Okay? So, the correct answer here, you find, is 5/9. What about this one? 9 over 100. Well, did you come up with 3 over what? 3 over 10. 3 over 10. What about radical 1 over 49? Or square root of 1/49th might be said. Well, what is the square root of 1? Square root of 1 is 1. Very good. What about 49? 7. Okay, now, one in the center there. Kind of a tricky one. Cube root of 8 over 27. Cube root of 8 over 27. So, something times itself 3 times is 8. Something times itself 3 times is 27. Did you come up with 2/3? I hope so. 2/3 is correct. 2 times 2 times 2, that's your numerator. 3 times 3 times 3, that's your denominator. And of course, we can't reduce 2/3, so we're all done. What about this one? 16 over 64. Well, we know that 16 is a perfect square. That's 4. 64 is a perfect square. That's 8. But consider now, are we all done? Can 4/8 be reduced? Well, in this case, the answer is yes, it can, and our final answer is 1/2. So don't stop there after one step. Always check to see if you can reduce. And what about 25 over 225? 25 over 225. Well, notice what we did here. This time, they reduced. 25 goes into 225. In other words, we know that 25 divided by 25 is 1. And think at the bottom here, how many quarters are in $2.25? Aren't there 9? So there's 9 quarters, so we can reduce this to 1/9. So right here's an example of them reducing first, then applying the rule, and we end up with 1/3. Alright, so keep an eye on that. And that's it for Unit 1-2. Once again, this video here, you can watch the lesson at thinkcentral.com. Type in the keyword MA8CA space, and then 1-5. And then just watch video example 2, and that will cover very similar to what we just did here together. Make sure you have a question for us tomorrow, okay? All right then. Talk to you soon.